Hi everyone! In this video we're going to talk about organizing quantitative data and some of the popular displays used to do so. So we're going to go through a number of objectives. Let's go ahead and jump right in. So first, let's talk about quantitative variables as opposed to qualitative, which is what we went over last. So a quantitative variable provides a numerical value or measure of individuals. The values of a quantitative variable can be added or subtracted and provide meaningful results. Basically, think of it as a quantity, something you can count, or like a numerical value. And we'll talk about countable and continuous in just a minute. So quantitative data are observations corresponding to a quantitative variable. Now, a discrete variable, and we're going to compare this to a continuous variable, is a quantitative variable that has either a finite number of possible values or a countable number of possible values. So the term countable basically means you can start counting it 0, 1, 2, 3, and so on. And a discrete variable cannot take on every possible value between any two possible values of that variable. So let's contrast that with a continuous variable. A continuous quantitative variable has an infinite number of possible values that it can take on and can be measured to any desired level of accuracy. So just a quick example, think about shoe size compared to the length of someone's foot. So if you were to measure the length of somebody's foot, if you use a very, very accurate ruler, you can get down to like hundreds of an inch or however accurate you want to be. And technically that's a continuous variable, a length, because depending on how accurate you are, it can be an infinite amount of values in between, let's say, inches, whole inch values. And then a discrete variable would be like the shoe size. Shoe sizes don't come in every single possible size for the length of a foot. We go to full sizes and half sizes. So size 9, 9.5, 10, 10.5, and so on would be a discrete variable. And it doesn't take on values in between those numbers. So last time we talked about qualitative variables based on like a quality or a category or an attribute. Now we're talking about quantitative variables like a quantity or counting, and quantitative variables can be either discrete or continuous. So just keep that in mind. Now, the first step in summarizing quantitative data is to determine whether your data is discrete or continuous. So let's talk about this. The data are discrete, and if there's relatively few different values, then what we can do is we can categorize the data into classes, and those will be our observations. If the data is discrete, but there's many different values, or just if the values are continuous, then what we are going to do is we're going to use intervals. So what would have been a class is an interval for the class. So basically what that means is because we can take on so many values in between two numbers, either because we have a very large amount of values in our set, many different values right here, or because our data is continuous, in that case we use intervals instead of like our whole number amounts. And we'll go through some examples so you understand this. So first, we're going to organize discrete data in tables. So our example here, the manager of a Wendy's fast food restaurant wants to know the typical number of customers who arrive during the lunch hour. And so we have some data given in our table, and this is of 40 randomly selected 15-minute intervals of time during lunch. So basically what happened was like 40 different days or 15-minute time periods during the lunch hour. The manager observed how many people went to the restaurant. And so notice, for example, in one 15-minute observation, 7 people arrived. In another 15-minute observation, only 1 person arrived, and so on. So there's 40 different observations in our table down here. So we're going to do our frequency and relative frequency calculations here. So just based on our raw data from the previous table, we had anywhere from 1 customer showed up to 11 customers showed up. and then you can just use tally marks as you go through the raw data. And then when you count those, you add those up, that's your frequency. Now notice for your relative frequency, you're going to divide the frequency by 40 because there was 40 observations. So 40 points of data on our previous raw data table. So 1 out of 40 would be the relative frequency, so 0.025 for one customer showing up. If we jump down here to 6, 11 people showed up, so 11 over 40 would be 0.275 or 27.5%. Now, right, the one I just talked about, so 27.5% of the 15-minute time intervals that were observed had 6 customers arrive. So basically, after watching 40 different time frames of 15 minutes, 27.5% of those times, 6 people showed up. All right, now let's construct histograms of discrete data. So a histogram is just constructed by drawing rectangles for each class of data. It's very similar to a bar graph like we've done in the past. The height of each rectangle is the frequency or relative frequency, depending on what we're talking about. And then the width of each rectangle is always going to be the same. But in this case, the rectangles touch each other. So that's the difference between a histogram and a bar graph. The rectangles touch each other. So we're going to construct a frequency histogram and also a relative frequency histogram from the information about our customers at Wendy's. So here we have our frequency histogram. Notice that the number of customers is our horizontal axis, and then our frequency, and then over here relative frequency, is our vertical axis. So notice the difference between a bar graph here. Your histogram, the heights of each rectangle touch, or just the rectangles touch, and then the height is the frequency or relative frequency. But also what I want you to notice is that when you draw the rectangles, you center them at the value down here, which is what we're calling the class. So the class with one customer showing up, notice the rectangle is centered on the 1. If you jump over here to 6, this rectangle where 6 customers showed up, a lot of the time, was centered on the 6, and so on. And based on our diagram here, notice that none of the observations had 10 people show up. So quick caution, the rectangles in a histogram touch, so that's different from a bar graph where they don't touch. Next, let's talk about organizing continuous data in tables. So let's talk about classes. Classes are categories into which data are grouped. When data sets consist of large number of different discrete data values, or when the data set consists of continuous data, we must create classes by using intervals of numbers. Okay, so let's take a look at this one here. This table is a frequency distribution, and it's created from continuous data. The data represents the number of mothers in the United States, ages 15 to 54, who had their 4th child in the year 2016. So the way you can tell it's continuous is because of the classes over here for ages. We're dealing with, like we have here, ages 15 to 54, but each class is a range or interval of values. So between ages 15 and 19, we have a number that had their 4th child in this year. From 20 to 24, a number that had that 4th child that year, and so on, all the way to the end of our age range, which is 54. Now the lower class limit of a class is the smallest value within that class, and the upper class limit is the largest value within the class. So from our first age range, the lower class limit is 15, the upper class limit is 19. In the class width is basically the distance, or how far apart you are from the lower class limit to the upper. You can just do some quick subtraction. Now you do have to be careful. The class range here is 5, so if you take 19 minus 15 here, for example, you're going to get 4. But you have to consider the next class. So the lower limit of the next class is 20. So we do 20 minus 15, and so the class width is 5. And you want to keep the same class width throughout your data. And so if you need to, you can just count in this case by hand. You could say, for example, down here, 50, 51, 52, 53, 54. that's 5 values. The class width is 5. Now, the thing with these intervals is you basically, if they're not given to you as a table, let's say you have raw data, you kind of just gauge it based on your values. And sometimes you pick a good starting point and a good ending point and a good class width, but sometimes you have to just do trial and error for what the class width should be. Now, one quick exception to the requirement of equal class widths is when you have what's considered an open-ended table. So a table is open-ended if either the first class has no lower class limit or the last class has no upper class limit. So for example, this table is residents of the US who had earned a bachelor's degree by 2017, and the upper, the highest class over here, the last class, it doesn't have an upper limit. So 65 and over is what makes this an open-ended table. Very similarly, if this said something like, let's say we add another category, another class, and we said 25 and younger, that would also make it open-ended. Let's take a look at this example here. So the data in table 12 right here represents the total fine, including late penalties, which is going to be in dollars, for a random sample of 50 parking and camera violations in the city of New York. So what we're going to do is construct a frequency and relative frequency distribution of the data. So we have 50 pieces of information here for our data. And notice this is raw data right now. It's not in any kind of organized fashion. And we're going to try to organize it. So to construct our frequency distribution, first we have to create classes of equal width. Now, we have 50 total observations. If you go back to the table, the lowest value, or fine, was $65, and the largest was $322.61. So we decide to create the classes with the lower class limit of 50 and then a class width of 25. Now, this is just sort of random. You don't have to pick the lower class limit of 50. You could say 60. Something just 65 or lower would work. And then the class width, we could just pick 25 or any number in between. We want to make it so where there's not too many classes. Usually between 5 to 20 classes is good. Now, we tally the data and as shown in the second column of the table, which we're about to go to. And so the third column is going to show the frequency of each class. And then we're going to conclude that between $200 and $224.99, we have the most frequency. Okay, so let's go ahead and take a look at that. So notice our classes. We do have 11 of them by the fact that we chose to start our lowest class limit at 50 and then make the class width 25. Now what I want you to notice is that the classes don't overlap. So even though 50 plus 25 would be 75, 75 is the lower class limit of the next class. And so technically, the first class goes from 50 to just below 75. Because this is in terms of money, we stop at 74.99 for that class. And then we do the same thing for the next class. Instead of saying 75 plus 25 to get 100, that would actually put us in our next class. We do just under that, and we go to 99.99. And we do this to create all of our class intervals. And then we just tally based on the raw data. And then we get our frequency. And then notice that the most common fine or penalty was from, like we said, $200 to $224.99. And then there was 50 violations recorded, so the relative frequency would be 13 out of 50, or 26% of the people got a fine that cost that much. Now here's some more information about your class intervals and the width. So the choices of the lower class limit of the first class and the class width are relatively arbitrary. It is just a choice, but you want to try to make a good choice. There's not one correct frequency distribution for a particular set of data. So I can have everybody try a different distribution. They might look a little different based on what you guys try, but you'll be working with the same data, but things might just turn out looking different. So constructing frequency distributions, it's somewhat of an art form. So you want to sort of look at all of the values in your data set and then think about how you can get a good amount of class sizes and what the class width should be. And then you want to just use the distribution that seems to provide the best overall summary of the data. Okay, so here's some more guidelines for determining the class limits and the width. So for choosing the lower class limit of the first class, choose the smallest observation in the data set, which was 65 for us, or a convenient number slightly lower. We actually went with 50. And then determining the class width, once you decide on how many classes you want, and sometimes you can do this later, but let's say you know you're going to go with 11 classes, or some number in between 5 and 20. And what you're going to do, you'll see, is how we're going to get a good class width from here, knowing how many classes we want to separate our data into. So we can do a computation. The class width is approximately the largest data value minus the smallest data value divided by how many classes we want. And so what you do here is you actually round up. You don't round off, you round up to a convenient number. So for example, our largest data value was $322.61 minus our smallest value of 65, and we decided on 11 classes. That's about 23.419. And so we're going to use a nicer number. That's where that 25 came from. So we use 25 as the class width because it's an easy number to work with. And then when you round up, so notice we didn't round off, we didn't just say 23. We ended up rounding up to a pretty nice number. You might end up using less classes than you intended, which is fine. So if you know how many classes you want to work with, then that's how you do this calculation. Or if you want to just play with the numbers and try different amounts of classes, you can do that too. All right, so next let's talk about constructing histograms of continuous data. So we're going to go ahead and construct a frequency and relative frequency histogram for the example of the fines that we just talked about from the city of New York. So here we have our frequency histogram and our relative frequency histogram. What I want you to pay attention to is your classes down here at the bottom, and it is an interval. So notice, for example, the first class was an interval or range from 50 to 75, and then the height is your frequency, or in this case, the relative frequency. There was no fines, no data between $75 and 100, so notice there's no rectangle here. Then from 100 to 125, we had, I think it was 7 occurrences, and so on. So your horizontal axis in this case, your classes, if you count them, you have 11 classes, and then your rectangle basically starts at the lower class limit and stops at the upper class limit when you draw it. Okay, so now we're going to use technology to graph the same thing. I'm going to go ahead and take you over to Excel, and we'll do it over there. Okay, so we're in Excel, and to use the stat functions, you might have to install an add-in. So let me just show you that real quick. First, you go to File, More, Options, Add-ins. So for me, my version, it's Analysis Tool Pack that I wanted to add. You might have to say, okay, restart Excel. For other versions, it might be called Excel Stat. So just check your version under your add-ins. Once you have that installed, for Analysis Tool Pack, it's under Data. So if you go up to the toolbar, click Data, Data Analysis. So we want to do a histogram. Now what I've done here is I've created our classes, but the way that Excel does this is you just put the lower limit of each class. And so notice these are the lower limit of our 11 classes. I'm going to hit OK. And I've already done this, so let me just back out and show you the starting point of all this. So the input range is your data. So we're just going to highlight all that. Okay, and I did type this in by hand, so if you're given just raw data, you might have to type that in by hand first. Now the bin range, if you leave this blank, Excel will evenly distribute amongst like a number of classes. It might be 6 or 10, it just depends. And but I created my bin range. That's basically the classes. So I'm going to say my classes go from 0 to 300, and then this output is just going to be where it's going to locate it. So I'll just say right there. Okay, and so now here's our histogram, and this table is a little bit off. Like 50 had 1, 75 had 0, so it's just like a little off by 1. Let's see if I can insert a cell. to shift it. There it goes. Okay. So if you notice, this histogram doesn't quite look like the one we just saw, but let's just adjust it a little bit, because a histogram, remember, the rectangles touch each other. So I'm just going to do a little bit of editing. Let's get the properties here to show up, and then let's click out of here and click back there. Okay, so I don't want a gap. I want them to touch. So there they go, they touch. But there's not any lines in between them, so let me just fill in a border line. And let's just make that black. Okay. And that looks pretty good. Okay, so there's our histogram. And I could adjust maybe the x-axis a little bit to make it look a little better, but that's pretty much what we've seen already from our example. But this is how you can do it in Excel. Next, let's talk about drawing dot plots. So a dot plot is just drawn by placing each observation horizontally in increasing order, and then placing a dot above the observation each time it's observed. So it's sort of like tallying, but in a organized manner. So we're going to draw a dot plot from our Wendy's data, if you remember, for people coming in 15-minute intervals at lunch. So from that data, if you recall, the observation, the lowest number was 1 person came to the restaurant, and at another time the largest was 11 people. And so we write 1 through 11 on our horizontal axis, and then we place a dot every time we count a value for 1 through 11. And so 1, there was only 1 occurrence when that happened. Remember, 6 was the greatest, so we place a dot each time we observe 6 people entering the restaurant. And then nobody came, if you recall, no groups of 10 came in, or 10 people, and then 11, the last one. So this is an example of a dot plot. Our last objective for this section is to identify the shape of a distribution. So we're going to go through 4 of them. The first one is uniform distribution. It's uniform, hopefully you can tell, because of how it looks. The frequency of each value is evenly spread out across the values of the variable. The next one is bell-shaped distribution. And so for bell-shaped distribution, the highest frequencies occur in the middle, and then the frequencies tail off to both the left and the right side of the middle. And then the graph kind of looks like the profile of a bell. That's where it got its name. The last 2 are skewed right and skewed left. So a distribution that's skewed right looks like this, where the tail sort of goes down, the tail of the graph goes down to the right. So to the right of the peak, it's longer than the tail to the left of the peak. So it's like longer toward the right side. And the opposite of this would be skewed left, because the tail is sort of longer in this direction to the left. Now, just a caution, we don't describe qualitative data as skewed left, right, or uniform. This is just for quantitative data. And it's important to recognize that data will not always exhibit the behavior that perfectly matches any of these shapes. So sometimes none of them can be used to describe our data. To identify the shape of a distribution, sometimes flexibility is required, and then sometimes people can disagree about what the shape is. So from our example for parking violations, notice the graph, it does have some symmetry, like the left and the right sides are both relatively low. There are some high points toward the middle, but it doesn't actually fit any of our descriptions we just went over. So it does have symmetry, but it's not bell-shaped, even though it sort of tails off to the left and the right. Okay, that's it for this one.